All right, here we are going over lesson 7.7, the odd questions. This was Tuesday's assignment. Remember that there were two aspects in the first set of questions. You first had to solve the inequality by isolating your variable. You then had to graph the inequality, okay? So I just wanted to walk you through how we would go about solving one of them. Remember, just like in yesterday's lesson, we want to use the inverse operation. So this is question number 1. If b is being divided by 3, we want to get rid of that divided by 3. We do that by multiplying by 3. So I would multiply by 3 on both sides. This is just like yesterday's lesson with addition and subtraction. It's just now we're using multiplication and division. Okay, these would cancel out. I end up with b is greater than 18. Okay, so that's the solving portion. I then would have to go ahead and graph. Okay, so like yesterday, why don't we go through how we would solve and then we'll go through how we would graph. Okay, so what I've done is I've already written the solved inequalities up on the chart paper, and we'll go back and we'll graph them together. Okay, well, together. So looking at number 1, we would have this. Okay, number 3, we would have to divide by 7 on both sides. So we're left with p is less than or equal to 10. In number 5, we would be dividing by 10 on both sides because x is being multiplied by 10. So we want to do the opposite. Okay, so we end up with 20 is less than x. In number 7, we would want to multiply by 4 on both sides, leaving us with 84 is greater than or equal to g. Okay? Looking at number 9, we would have to multiply by 4 on both sides, and remember that 0 times 4 is 0, so we're left with h is less than or equal to 0. In number 11, we want to divide by 8 on both sides. So we're left with t is greater than 3. In number 13, we want to divide by 13 on both sides, leaving us with y is greater than or equal to 8. And then in number 15, we want to multiply by 6 on both sides, leaving us with c is less than 78. Okay, so that is the solving portion of these inequalities. The next thing we need to think about is the graphing. In yesterday's video, we talked about the 3 important things when graphing. Where is the dot going to go? Remember, it's always going to go at the number in which the variable is being compared to. Is it an opened or a closed dot? Okay, regular symbols have an open dot. The or equal to symbols have a closed dot. And then the last thing we need to think about is which way our arrow is going. Okay, so which way our arrow is going to indicate where the variable would be. If it's saying that b is greater than 18, we'd want to make sure that that arrow's off to the right because that's where the numbers that are greater than 18 are. Okay, so in number 3, I would have, I always put a 0 here just for some context. Okay, I would have an open circle at 18, and b is greater than 18, so it's going off this way. Okay. In number 3, okay, my dot's going to be at 10. It's going to be a closed dot because of this line. P is less than or equal to 10. Less than is off to the left, okay? In number 5, 20 is less than x, or read it backwards. X is greater than 20. So again, I'm going to have an open dot greater than 20 off to the right. Okay, in number 7, 84 is greater than or equal to g, or if we read it backwards, g is less than or equal to 84. So again, I'm going to have an 84, I'm going to have a closed dot because of this. G is less than or equal to, that is this way. Okay, in number 9, okay, I've got h is less than or equal to 0, okay? 0. I'm going to have a closed dot at 0. H is less than or equal to. That means it's off to the left. In number 11, t is greater than 3. So again, I'm going to have an open circle. T is greater than 3. That's off to the right. Okay. In 13, we've got Y is greater than or equal to 8. That is a closed dot. Greater than would be off to the right. And then in 15, C is less than 78. Open dot at 78. Arrow to the left for less than. Okay, I know I'm going kind of fast. You're always welcome to pause. Okay, moving on to the next set of questions, we had to do two other things. We had to first translate, we had to write the phrase as an inequality, and then we had to solve. Okay, so those are the two things, no graphing in this particular section. So in number 17, it says a number Q divided by 14. Okay, so Q, oh, that's a bad Q. Q divided by 14 is no less than 4. Cannot be less than 4. Could be 4, can't be less. So this is the symbol that should be there. Okay, and if you use the little division symbol, that's fine. The Q would just be first. Okay, so in order to solve this, I'm going to switch markers for a second. In order to solve this, I'm going to multiply by 14 on both sides. Those cancel. This ends up giving me, what do we end up with? 56. Okay, so I end up with Q is greater than or equal to 56 in that one. Okay, so the written, the solved. Those are your two different answers. In number 19, it says the quotient of a number Z and 7. Again, so quotient, that's division. The quotient of Z and 7 is at least 12, at least. 12 is the smallest it could be, so it could be more and it could be exactly. So it is at least 12. Okay, so there's your written inequality. Now we need to solve. We want to get Z by itself. We're going to multiply by 7 on both sides. I'm going to multiply by 7 here, multiply by 7 here. These end up canceling out. I end up with Z is greater than or equal to, what does this give us? 84. Okay. 21, same thing. We had to translate from the phrase into the inequality. A number G multiplied by 13. Okay, so I would go like this. If you had G times 13, that's fine too. Is no more than 117. Cannot be more than 117. That would be this symbol here. Okay, it can be 117, but it can't be more than. So then again, in order to solve, I want to divide by 13 on both sides. Divide by 13, divide by 13. I get G is less than or equal to 9. Okay, so the black is the written inequality and the red is the solving portion. The error analysis in number 23. You'll notice that what they did was they subtracted 2 from both sides. What they should have done was divided by 2 on both sides, okay, to get n is greater than or equal to 14. That's what they should have done. In number 25, here's our word problem. It says that a table is 3 feet wide. The length of the table can be adjusted as needed, and maybe you have a dining room table like this where on the holidays you expand it and put in those leaves, or you can shrink it if you want. Maybe not. So we need to have at least 24 square feet. We can have more, we can't have less, okay? So that language of at least 24 square feet, 24 square feet is the smallest it could be. It could be bigger, okay? So this symbol right here is going to be set up. 24 square feet, the square footage we want, has to be less than or equal to what our table setup is. Okay, when we're thinking about area, that's a length times width formula. We're given one of those dimensions. We're given the 3. What we're not given is the length. Okay, so our directions for the word problem is to write and solve an inequality. There's your written inequality. Okay, and again, if you have it flip-flopped, you just want to make sure that the mouth is opening up to the 3L, or the 3 times L. And then in order to solve, we want to divide by 3 on both sides. And what we end up with is 8 is the minimum length for this table in order to achieve the 24 square feet that we want on the entire surface of the table. Okay, so I've also posted the the group meet that we had on this particular lesson. Some of the questions we went over again, but that might be helpful for you. And as always, if you still have questions, just make sure you email me and hopefully we can get that straightened out. Have a good night.